Okay, so this talk is somewhat heavy on code simply because it's difficult to talk about scope and context without showing real examples in code in JavaScript. So the slides are up online right now. Here's the URL. If you have trouble reading the code that's on the screen, I highly recommend that you load this up in your browser just so you can read the code examples. So that's how big the code's going to be. Okay, let's talk about a roadmap really quick. We're going to be talking about scope from the ground up, giving some definitions and showing some examples of its usage. Then we're going to talk about what I like to call the magic variable this, and talk about how that relates to context in JavaScript. Finally, we're going to talk about what's coming up next in ECMAScript 6 in terms of scope and context. In terms of the difficulty level of this talk, my intent is to give a somewhat comprehensive overview of scope and context. So that means that in the beginning, there will be some review for those of you that are already experts, but my hope is to move on to more advanced topics and sort of have something interesting for everybody. That said, if you want the non-fundamentalist talk, go next door. I promise I will not be offended. You can do so anytime during the talk. I will probably do that throughout the conference myself. Okay, so let's start just by looking at scope from the very ground up. So what is scope? I like to think of it as the lifetime of a variable. A more formal definition is that scope maps a name to a value in a given environment. So in this code block, for example, we define the variable sum in two places. And then at the bottom, we get down to the statement return sum. It's the job of scope and scope resolution to say, hey, I've defined this in two places. What value should I return at this time? Which definition of sum should I return? That's what scope does. A lot of languages define scope by using blocks, and by that I just mean curly braces. So in C, for example, if you go into an if statement, the variables that you define there are private to that if statement, meaning once you leave that block, the variables disappear. That's what scope means. It's just a private area of code. So in C and Scala, and there's tons of other languages that use this type of block scope, it's easy to create lots of nested scopes just by opening curly braces. In JavaScript, that is not the case. So this is the same code written over in JavaScript on the right, and you can see that we're only in one big scope because you cannot create scope with blocks in JavaScript. So if you can't create scope with blocks in JavaScript, how do you create scope? JavaScript uses functional scope, and it means what it sounds like it means. Basically, whenever you're inside of a function in JavaScript, that is what is giving you a private scope. So in this function here, any variable I define with the keyword var will only live inside this variable. And the second that my function leaves, that variable will disappear. Since the only way to create private scope in JavaScript is to be inside of a function, there's lots of different ways to sort of create these on demand. The most popular way is to use a self-invoking function. And what this does, when the JavaScript interpreter gets to this line, it'll immediately execute this function and therefore give you a private scope on demand because everything inside of this function is private. And so the way that this works is that you write the function like normal, but then you surround it with two parentheses to make it an expression. Then you can run that expression using two more parentheses at the end. So it looks kind of weird if you're not used to this concept, but the main important takeaway is that you can write self-invoking functions like this to create an immediate scope. Okay, so you now know enough to play a very exciting game that I like to call Guess That Scope. I'm going to ask 3 questions. They're going to get progressively harder, and this will sort of just test your knowledge of what we've covered so far. And feel free to heckle and yell them out if you know the answers. Okay, so first up, what gets printed on this last line here, console.log, episode 1? Yes, the King's Road gets printed, of course, because we're only inside one scope here. So even though we've opened an if block, we're not creating a private scope. So when we redefine episode 1, which is completely legal, we're just overwriting our previous entry. So when we go to console.log it, we get the King's Road. Okay, next question. What gets printed here? Heard a few different answers. They are actually both wrong. It's not undefined, and it's not winter is coming. It's a runtime error. So when we're in the self-invoking function and we define this variable, once we leave it, that variable disappears. So it's not undefined, it's not winter is coming, it just is a runtime error. The variable does not exist. So this is one of those self-invoking functions. We created a mini scope to create private variables, and the second we leave, we can no longer have access to those. This is probably the trickiest example of the three. Try to figure out what gets printed when I call print name and pass in an argument that has the same variable name as a variable that's already defined in the environment. So what do you guys think gets printed? Yes, good job, smart bunch. It's a golden crown. What this shows is innermost precedence in JavaScript. So even though we've defined episode 3 in our scope, we are redefining it when we name an argument with the same name as that variable. So we define episode 3 as our argument closer to the time that we use it here, where we log out, where we do console.log. And so that's what will take precedence, even though we've defined it in a parent scope. All right, so up until this point, I've avoided mentioning an important pitfall in JavaScript, and that is, of course, the global scope. Without using the keyword var, variables will leak up to the global scope, which in a browser is the window object. So here's the exact example we saw in question 2. The only difference is that inside this self-invoking function, I am declaring this variable without var. So when I leave this function and console.log out that variable, I can access it. It's still there. It did not disappear with that scope because it was never in that scope. So I didn't use the keyword var, so it got yanked up to the global scope, meaning anytime I want to access that on the page, any script that's running has access to that variable. So I'm sure that you all know that global scope is bad and you should not use it. It's sort of hammered into us from day one as JavaScript developers. But why is global scope really that bad? So Douglas Crawford has this great quote that says, "Browsers are the most hostile software development environment imaginable." And I think that a big reason this is the case is because of global variables. So along with the code that we write as application developers, a page is executing tons and tons of third-party JavaScript, be it Google Analytics or even jQuery or underscore or multitudes of ad platforms, you name it, and our pages are executing it. If you use global variables, you are giving access to these third-party scripts to change your application code. So if you store the variable result from some calculation in a global, that means that any other script running on your page can change the value of that variable at any time without notice, and that can obviously really screw with your application logic. So that's the main takeaway there. I found this really great blog post called "How One Missing VAR Ruined Our Launch." And the main gist of this is that this was a Node.js company. They were launching their product, and they were inadvertently storing a user's incoming request in a global variable because they did not use the keyword var. So what this means is that anytime there was more than one user on the site at any time, they were just overriding each other's incoming requests. So the responses they were getting out were other users' responses. So obviously that is a very bad thing, and you can avoid that by not using globals. Quick way to detect globals to make sure you're not leaking them to the global namespace is just do object.keys and pass in your global object, which in a browser is window. And this will just list out all your global variables. So if you see anything suspicious, then you know that you might have some refactoring to do. Okay, so let's move on to talk about context, and specifically what I like to call the magic variable this. So up until this point, we've known the value of a variable by looking in the program text above it to see where the definition is. We can visually see where a variable gets defined, and then we know what it'll be when we go to use it. And that's called a lexical scoping. However, there are ways to define variables that do not depend on text that comes before it in a program, and that's called dynamic scoping. So context in JavaScript uses dynamic scoping. And the way I like to think about context is that if a function is a sentence, context is sort of like the subject of that sentence. It's who or what a function is about. And the way you get to a function's context is through the variable this. So before we get into the mechanics of how to explicitly set the value of this, which we absolutely will do, I think it's important to look at why this is so hard for a lot of developers that are learning JavaScript. So like I said, we're used to lexical scoping, where we can see the value of a variable visually by looking at the code. But this uses dynamic scoping, which depends on how the function is called that it actually lives inside. So we're just much less used to thinking about this type of scoping and variable assignment, and so it makes it difficult to understand what this is at any given instant. However, I do think that we all kind of sort of have an intuitive sense of what this should be, just from the very beginning. So if we look at this jQuery event callback, I'm sure we're all very, very familiar with this type of syntax. So we say button.onClick and provide a callback function to run. We know that this will refer to the button that was clicked. It just sort of makes sense. Similarly, in a jQuery element loop, if we're looping over a set of matched elements, we know that in each time that callback function runs, this is going to refer to each element in that matched set. So it's sort of the subject to the sentence example. So without further ado, here are the 4 ways to know what the value of this will be in any given situation. Might look like a lot here, but I think you'll find that they're really easy, and so let's just go through a quick example of each one. So the first way to know the value of this is that if you call a method on an object, this will be object inside that function. So if I call user.alertName, inside alertName, this is always going to be user. So in this case, it would alert out my Twitter handle. The second way to know the value of this is to explicitly set it. And you can do this using a function called .call. So in JavaScript, functions are objects. And like objects, they can have properties and they can have methods. So instead of calling a function the normal way with 2 parentheses, you can instead access the call method of your function. And call accepts arguments. The first argument that you pass in will be the this value that you want your underlying function to have. So by calling user.alertName.call and passing in this object, when alertName runs, it'll know to alert out at AndrewWK, which is a hilarious Twitter handle you should all follow, because we're explicitly passing it in. I call this 2-part B because .apply is a near identical twin of .call. The only difference is how you pass arguments to the underlying function. So at the very bottom here, let's start there. At the very bottom is the .call example we just saw. But in this function, in alertName, you can see that now we're accepting an argument. So the way you pass arguments through using .call is that you just list them out after your this value in a comma-separated list. In .apply, you group them all together in an array. So even if your function accepts 9 arguments, you would just pass them as the second argument to .apply as an array. So it's a very small difference. The third way to know the value of this is to use the new keyword. So when you use new and call a function, this will start out as an empty object in your function. And then you can build up that object as you go through your function. And the interesting thing about new is that it returns back to you the this value when that function is done running. So in this example, if I call new user, my function starts running. This starts out as an empty object. Then I'm going to build up stuff onto this object. So I'll say this.handle equals the argument that I passed in. Then that gets returned to me. So then I have a variable that stores this state internally. So the main takeaway is that if you use new, this will be an empty object. Finally, the last way is to use .bind methods. And many of the libraries have this. jQuery's is called $.proxy. Underscore is underscore.bind. And most browsers do now offer a native .bind method. The way this works, the way they all work, is that they accept 2 arguments. The first one is the name of the function that you want to call. The second argument is the value of this that you want to be there. So those functions will return you a new function that when you run it, it'll satisfy those conditions. So when I call $.proxy, pass in the name of my function, alert name, the value of this that I want to be there, then that'll give me a function that I can either immediately call or store in a variable for later use. And jQuery underscores and the native bind all have the same API, so these all work the same way. Actually, we'll get to that later. One quick thing I wanted to say about the performance of these is this interesting JS perf test. It's comparing native bind, jQuery's proxy, and underscores bind with a method that doesn't use bind at all. In the last one, it might be hard to see down there, but it's just using .call, which we saw in an earlier rule. And you can see that .call very decidedly wins in this example. So it's not always possible to use .call. Sometimes you do need to use .bind or $.proxy, but just food for thought that it may be to your advantage to not use these bind methods, instead make your own closure, which we'll cover in a bit using .call. Okay, so that's it. That's all there is to it. There are 4 ways to set the value of this in a function. Number 1, call a method on an object, and this will be the object. Number 2, use .call and .apply to explicitly pass in the value of this. Number 3, use new, and this will start out as an empty object. And 4, you can use bind methods, either the native one or a multitude of third-party alternatives. An important thing to remember, though, is this little 5th rule that I've tacked on, which says that if none of these 4 rules are used, this will default to the global object. Oh, okay, so it's time for another game. I know you're all excited about it. This time it's guess that context, so same type of deal. So first question, what is this? Self-invoking function will run, what gets logged out? Yes. It's the global object. So if we're running this in a browser, it'll be window. And this is just because we're not using any of the 4 rules that we just discussed. So it defaults to the global object window. Next up, what is this? Kind of spelled out for you. Yes, it's background colors. And the reason I chose this example is because many people assume that this has to be an object, but that's actually not the case. You can pass in whatever you want this to be. You can pass in an array, you can pass in a string, it can be whatever you want. So here I'm just setting up a function statement and then immediately calling it, passing in my array that I want this to be. Last one, sort of a softball, user.print. When print runs, this will be, of course, user, yes. So whenever you call object.method, this will be object. Okay, so that's it. Those are all the rules. And so now that we know them, we can take a look behind the scenes at these popular libraries and see how they leverage these concepts to give us these APIs in jQuery that we all rely on and use every single day. So in this example, we are matching a selector, div.disabled, and then calling jQuery's .each function on it. And then in the callback, we're just going to log out some information about each one of these elements that we matched. So this is where the sausage gets made. This is jQuery.js, line 561. And this is the implementation for that each method that we just saw. And what I want to highlight is what's here in the red box. So we get into a for loop, and it's going to loop once for every one of our matched elements and track that index in a variable I. And then you can see that all it's doing is taking your callback and calling .call, passing in each one of those matched elements by just using the I index as your this. So that's how you get, that's why when you're in a .each callback, this refers to each one of your elements that you would expect it to. And then also from this, we can see that .each is passing additional arguments into your callback function, whether you like it or not. So as your first argument, you get I, which is the index. And that's what enables you to use index as an argument in your callback function, even though you didn't have to do anything to set it up. So that's how that works. One thing I do want to point out is that it's important to sort of beware of callbacks because your context can get hijacked very easily. So in this situation, we have a button that we're registering a click handler on. In our callback function, we want to wait a second before actually doing something. So if we just do a set timeout and then try to do $this.add class clicked, it's not going to work out for us because here we're just giving set timeout an anonymous function. We're not following any of our 4 rules, so this is going to be the global object window. So it doesn't make any sense to add a class to the global object window. It's not what we want. So a common way to fix this is to store your context into a local variable. And of course, there are tons, and there's dozens of ways to solve this problem. You could use bind, you could use lots of different methods. The one I wanted to call out here, though, is a common practice where you store your context, this, at a time when you know exactly what you want it to be. store it in a local variable, and then just call that local variable down in your callback function so that you know you're calling the right this. Many of you have probably heard the term closure. And all a closure is a function. It's a function declaration that has some information about the environment it's supposed to execute in. So it sort of closes over its own environment. So what we're saying here when we define this callback function, we're saying here's the logic, but also here's some information about the environment I want this to execute in. And we're doing that by storing the underscore this. Also, I know the title of my talk is underscore that. They're used interchangeably. Underscore this, underscore that, self. There are a few different conventions. They all do the same thing. OK, so that was the current state of scope and context in JavaScript. But we have an exciting future ahead of us with ECMAScript 6. There are some really great improvements, and a couple of them have to do with scope and context. The first one I want to highlight is the keyword let. And even though I tried to hammer into your heads earlier that there is no such thing as block scope in JavaScript, in the future, that's not going to be the case. So in the future, you'll be able to use this keyword let to say, I want a certain variable to be blocked scope. We'll show an example of that. The next one is arrow functions. And if any of you have used CoffeeScript, this will look familiar when I show you an example. Arrow functions are interesting because they inherit their context, their this value, from their parent scope. So I'll show you an example of that as well. Let's start with let. So let gives a variable block scope. So if I enter into this if block and I'm in a browser that supports ECMAScript 6, this will say, hey, keep this variable local to whatever block or statement I'm currently in. So when I leave this if block, local var will be undefined. So that's something to look forward to. The browser support for let is getting there. There's no support in Safari at all, so it's definitely not something you'd want to use in your client apps quite yet. But if you want to experiment around with it, there is support there. This next topic in ES6 is arrow functions. So to break this down, let's start by looking at the very bottom example here with the current ECMAScript 5 declaration. So this is what we're all used to, where I declare a function using the keyword function. In ECMAScript 6, you'll be able to define functions using this fat arrow syntax, as sometimes called, where you eliminate the word function, you just put your params in parentheses, fat arrow, and then open a block, and that is a way to define a function. And if you're actually doing this in one line, you don't even need the block, but if you're doing it on multiple lines, you do need the block. The reason this is interesting is because it inherits its parent context. So if we look at this example that we just saw, where we're using a closure to save our value of this and pass it down into a callback, this is the way you have to do it if you're using this method in ECMAScript 5. However, with arrow functions, you no longer need to do this because they're just going to inherit the value of this from the parent. So when I run button.click function, I have my set timeout here. I don't have to store my value of this because the arrow function will just inherit from the parent scope. So it's all set up for you. The browser support is decidedly worse for arrow functions as it currently stands. The only browser I could find that has support for it is Firefox 24+. But I did check, and this is on the track for implementation. It hasn't been removed or anything. It's just browsers have not implemented it yet. So it will get implemented. It'll just take some time. Something to look forward to. OK, so where can you go from here? You now know all the mechanics and the rules that govern scope and context. There's not very much to it, and I've told you all of the hard rules. And these are two really important concepts in the front-end world nowadays. There are module loaders like require.js that sort of mix private variables with public exports to great effect. These concepts enable full-fledged MVCs in the browser like Backbone.js and others. And it also enables functional programming toolbelts like underscore by passing around context effectively. And there's actually a talk at this conference all about functional programming, which I'm actually stoked to see. And that's all I got. So I think we have 3 minutes for questions, if you guys have any.